energy. Now we're going to be looking at the gravitational potential energy, which is basically energy due to gravity, essentially. So, what's going on here? Well, um, it it turns out how high you go up in the world, literally. So if you go up a building with many floors, really high building, you're really high above the ground. Something like this, right? So if you have a ground, oh, and then you have a big building, and so on. Uh, if you're on top of the building, let's say, then you're above the ground, right? That's your height. Okay. Now, when you go above ground, you gain gravitational potential energy, or we just call that GPE for short, right? So the higher you go up, the more gravitational potential energy you get. The reason for the idea behind that is because, say, not to be too bleak, but if the person falls down, there is going to be energy involved, right? And you can imagine the higher up you are, the more disastrous the fall will be. Because gravity's working against you, right? So the idea is, as you go up in height above the ground, gravity's working more and more against you. Okay, so the energy that you gain as a result of that, if you were to fall down back to the ground from such a height, that is due to gravity. So this is gravitational potential energy. Okay, so how are we going to work that out? Well, actually, as we discussed last time, work done against gravity with this specific formula is mgh. So again, mass g, which is this number 9.8. Usually, again, it's like pi, it's an ongoing number, but usually we say 9.8. So M again is the mass, G is 9.8, and H is your height above ground, the vertical height, I must say. Okay, now we said it's mgh. Now that's the work done against gravity. So what you're doing is, say you climb up a mountain, you're climbing up against gravity. Okay, that's the idea. So that means the work you're doing to pull yourself and push yourself up a mountain, let's say, um, the work done you are to move forward is because of gravity. So you're trying to defy gravity by moving up and up. Okay, and so that means that if you're if you are using energy to go up, then it's going to be the same energy once you come back down. So it turns out that this gravitational potential energy, GPE, is also mgh. Okay, and so there we are. Okay, so to illustrate, once more, uh, if we're on the ground, our GPE will be 0 because there's no height. Okay, you're on the ground. Okay. However, if you're then on the building, again the same building, if the height is h, then your GPE in this instance is going to be mgh. Okay, so you gain gravitational energy as you go up, specifically mgh, your mass times your times g, which is 9.8 roughly, times your height that you've gone up. Okay, and the height increases, h increases as you go up and up, and that makes sense because if you fall back down again off a tall building or something like that, it's going to be a greater fall. Okay, so that's the idea. Essentially, gravitational and gravity energy is calculated by this mgh. Okay, let's have a look at some examples. So we've got this question here first. Find the change in potential energy. So potential energy, gravitational potential energy. That's what it means. Find the change in gravitational energy of each of the following, stating in each case if it's a loss or a gain. Okay, so we look at the first bit. we're told a woman of mass of 55 kilograms is ascending a vertical distance of 15. Okay, so if we just draw very simply what's going on here, have this woman, this little person here. Okay, the mass of the woman's 55 kg, and they're going up. They're ascending, so they're going up 15 meters. So they're going to go up like this, 15 meters. Okay, that's my height. Okay, so that's my height. That's the vertical distance there. Okay, so this woman has gone up 15 meters. So the change in the gravitational potential energy, or I'm going to shorten to GPE. Okay, so again, the formula is mgh, mass times g, which is 9.8, times h, the height. Well, actually, we know that the mass is 55, the g is 9.8, and height, we've gone up 15, so times by 15 from the height there. Okay? Very simply, put all that in the calculator, and we get 8,080 joules. Okay, and that is my change in GPE. Okay, let's have a look at the next question. So now we're told a man of mass 75 kilograms is descending, so going down a distance 30 meters. Okay, now we have this man here. They're now going down 30 meters. The mass is 75 kilograms. Okay. So again, they want me to work out the change in the gravitational energy here. Okay. So in this case, the change in GPE of the person here, well, again, that's mass times g times h, the height. Okay, so the mass is 75, g is 9.8. Now the height. Now the change in GPE here is they're going down 30. So we need to so what we say is negative 30 here, because it's going to be a negative change, okay, because you're going downwards. So if I work that out, I have minus 22050, 22,050 joules. Now it's a negative because it's going to be a negative change, okay? And so what that means is it's going to be a loss in energy. So the loss in GPE, the loss in the gravitational energy is going to be 22,050 joules, right? So there we are. So the negative means it's a negative change, so it's a loss in energy. We're losing energy, so that means the change in the energy is negative. Okay, that makes sense. Whereas in the first question, the person's moving up, so we're going to gain energy. So actually, this is going to it's going to be a gain in GPE in the first case. Okay. And so there we are. So very simply, gain gravitational energy if we move up. And then in the second example, we lose gravitational energy if we go down. Simple as that, right? Up, we gain, lose, we go down, we lose it. Okay. And so there we are. So this example then, we're told a load of bricks of total mass 30 is lowered vertically to the ground for a distance of 15. Find the loss in, again, potential energy or GPE, gravitational potential energy. Okay, so again, we have a pile of bricks. I draw the little box, represent it. The mass is 30 overall, and it's being lowered vertically, so it's going down. And the distance down is 15. So that's by height downwards. So therefore, my potential energy, my GPE, again, is going to be mgh. My mass is 30, g is 9.8, and height, well, it's going down by 15, so the height is 15. I'll work that out. But that'd be 4,410. And it's a loss, okay. it's a loss in energy because it's going down. Okay, it's going towards the ground. It's losing gravity, if you will. So there we are. Okay, so we've then got this question here, and here I'm told a woman of mass 80 kilograms climbs a vertical cliff face of height h. Her potential energy, again gravitational potential energy, increases by 15.7 kg. That's kilojoules. Okay, find the height of the cliff. Right. So again, what's going on here is we've got this woman, we've got a person that's going up, climbing up a cliff. Okay, and the height travelled upwards. We just said it's h. Okay, just h. The mass of the woman is 80 kilograms. Okay, so then we can work out the GPE, the potential, the gravitational potential energy, which is mgh. Well, the mass is 80 times g to be 9.8, and height, which is just h, right? We just leave it in terms of h. We can simplify this. So 80 times 9.8 is 784. Lots of h. Okay. Right. I'm also, however, told how much the energy, the potential energy, increases by. Okay, so as she climbs up the cliff, that's how much energy she gains, right? So that means the GPE has to also be this 15.7 kg kilojoules. Okay. However, we can't just then equate this to what we've got because of the units. There's an issue with the kg, as you can probably guess, right? Our formulas have to work with specific units. And we've been using joules all the way through. It has to be in joules, not kilojoules, okay? I emphasize that again with every formula, GPE is an energy in joules specifically, not kilojoules. Right, GPE has to be in joules. Okay. Now it's kilojoules, so that means if you remember kilo, as in kilograms or anything like that, or kilometers, it means 1,000 lots, 1,000. So to get it in joules, we need the times by 1,000. Let me do that. This would be 15,700 joules, and that we can use. Okay, so the GPE, the potential energy gained. Why is it a gain in energy? Because the person's climbing up. It's going upwards. Okay, she's gaining height. So that means it has to equal this 784h. Okay, so 15,700. Therefore, we get the equation 784 lots of h is 15,700. So simply then, to solve for h, we can divide by 784. Then we get the answer, h to be 20.03 meters, and that will be to, let's say, 2 decimal places. That's the answer. That is the height of